Let's consider what the parent function of y equals cotangent theta looks like. Well, we know that cotangent by our quotient identities is cosine theta over sine theta. So we know also that we can't divide by 0. So sine has to be 0. Well, let's consider our sine function. We know sine function goes 0 max, 0 min, 0, and that's from 0 to 2 pi. So we have 2 pi and 0 there. And so anytime we have these zeros for our cotangent function, you guessed it, those are going to become vertical asymptotes. So I have vertical asymptote at 2 pi, at pi, let me make that a little better, and at 0. So those are our, and by the way, those would continue on negative pi, negative 2 pi, etc., etc., etc. Let's just look at one of these periods. I chose the asymptotes 0 and pi. So I forgot about the 2 pi 1. I forgot about the negative pi 1. I'm just concerned what's happening between 0 and pi. And I'm looking at this parent function, cotangent theta, and I'm choosing some points here. I'm choosing pi over 2. So I want to know what's happening at pi over 2. And then I went halfway between pi over 2 and the first asymptote, which was pi over 4. And then I did halfway again, halfway between pi over 2 and pi is 3 pi over 4. Some unit circle time. Pi over 4. Well, let's consider when we have cotangent of, let's substitute in pi over 4. Well, if I'm looking at pi over 4, that's in the first quadrant. Here's pi over 4. And I know that across I have root 2 over 2, and adjacent I have root 2 over 2 and 1. Now, if I look through this reference angle, cotangent is x over y, or adjacent over opposite, which is root 2 over 2 over root 2 over 2. They're both positive, so I'll have 1 there. So I'm up 1 right here at pi over 4, comma 1. So there's my first point, pi over 4, comma 1. So I found 1 there. Continuing along, I'd like to know what's happening at pi over 2. So if I'm on my unit circle, remember pi over 2 is up here. And I know that this is the point 0, 1. And I know cotangent of pi over 2. Remember, cotangent is adjacent over opposite. Or, critically, we say x over y, which would be 0 over 1, which is 0. So here I get 0, and my point is pi over 2 comma 0 gives me that nice point right there on my graph. I have these points, pi over 4, 1, pi over 2, 0. Let's look at 3 pi over 4. If I'm looking at cotangent of 3 pi over 4, of course I want to make a little unit circle, and I know that 3 pi over 4 is here. So there's my obtuse angle. If it's 3 pi over 4, well, that point pi is 4 pi over 4, so our reference angle is pi over 4, and we're going to look through that. Well, this is going to be negative root 2 over 2, and here is positive root 2 over 2. Adjacent over opposite is negative root 2 over 2 over positive root 2 over 2, which gives us negative 1. So our result here is negative 1, and our point is 3 pi over 4, comma, negative 1. Now, take a look at our graph. We had this point, pi over 2, comma, 0, and now we have 3 pi over 4, comma, negative 1. This is for the parent function. So look at our graph. It's going to come down, down, down. Go through this point, and continue. So we can see it's a constantly decreasing curve. I have asymptotes at 0 and pi, points at positive pi over 4, 1, pi over 2, 0, and 3 pi over 4, negative 1. You know I have to do it. I really feel like we should talk about its domain and range. The domain, well, I can say it's all real numbers except x cannot equal, let's pick one. How about this one? X cannot equal 0 plus, what's the jump to the next one? Well, the period is pi n, where n is an integer. So I write n-e-z. Lets everyone know n is an integer. I save time. I don't have to write out n is an integer. And the range, look, it's going from all the way up at infinity to all the way down at infinity. So interval notation like that, no problem.